Hello, good day, students. Today we are going to expand and go in details what we just reviewed in the previous class. So in the previous class, I gave you the overview of what we need to do in this class. In lecture 1, we say we look at the overview of data mining, where we define data mining and different tasks, then applications, the types of data, knowledge discovering, and the tools they were going to use to apply these things. So today we go in depth in our lecture 1. In our lecture 1, part 1, we critically look at the data mining. And we know that the data mining, as we have explained before, is the discovering of patterns and knowledge from data. You can define it as the process of extracting meaningful insights, trends, and patterns from large datasets using techniques from statistics, machine learning, artificial intelligence. It is a crucial aspect of data analysis and is widely used across industries to make informed data-driven decisions. Data mining involves various tasks that help in discovering patterns, trends, and relationships in large datasets. These tasks can be broadly classified into supervised learning, where labeled data is used, and unsupervised learning, where patterns are detected without predefined tasks. We still have other, when you come critically to machine learning, we have other types that we call reinforcement learning, but for now, we're going to concentrate on supervised and unsupervised learning. So let us look at data mining versus machine learning. Data mining is the process of discovering useful information from raw data, as we all know, while machine learning focuses on building models that learn from data and make decisions. So these processes of discovering information can be automated to make automated prediction by building models. So that is what machine learning does. So these two terms can be used interchangeably. Data mining often serves as a pre-processing step for machine learning. So when you are building a machine learning model, all those pre-processing steps you take, including your data, scaling your data, and transforming your data, they are all data mining process. So the key points here is the data mining helps in pre-processing data, cleaning, pattern discovery, feature selection. Machine learning model use this data to make real-time prediction. Real-time prediction is not only fraud prediction, real-time predictions. It can be applied in different applications, not only in fraud prediction. So combining both improves accuracy and the efficiency. So in this class, we are going to use both data mining and the machine learning interchangeably. Before now, we always talk about data mining, data mining. Now, present days, we have machine learning because it enables us to automate our decision making. So in this table, we just put it in a nutshell, data mining and machine learning. The definition, you can see it, the goal. The goal of data mining is discover hidden pattern and relationship. The goal of machine learning is to learn from data and make prediction. Approach. In data mining, you can use statistical techniques, pattern recognition, and rule-based algorithm. In data machine learning, we use AI techniques like deep learning and neural network. So when we are doing building a machine learning model, we use both data mining techniques and also to clean our data before we automate our model. Human intervention require human defined rules and parameters. Machine learning can automate learning and improve over time. Example techniques, clustering, classification, association rule, mining. Machine learning, we call it classify everything under supervised learning, unsupervised learning, and reinforcement learning. Use case, fraud detection, market basket analysis, customer segmentation. Use case, self-driven car, speech recognition, personalized recommendation. Output type, provide insight from past data. Here, make prediction for future events. Dependency on data. Analyzes historical data for pattern. Here require label on label data to train the model. So personally, I use this interchangeably. So we're looking at what is in current time or modern time when we are building our machine learning model. We are going to use all these techniques and interchangeably. You can take it as machine data mining technique or machine learning techniques. As I told you, in recent time is used interchangeably. Yes, let's move on. So we are going to continue with classification. What is classification? Classification is a data mining task that assigns predefined labels or categories to data points based on their attributes. It is widely used in applications where the goal is to categorize new data into known groups. So as opposed to regression, classification and regression are two fundamental types of supervised learning techniques used in data mining and machine learning modeling. Both involve predicting an outcome based on input data, but they differ in the type of output they generate. The output in categorical or classification, the output is discrete. That is categorical values such as yes, no, one, zero, span or non-span. So when we are building a model, we are going to encode these two values. You can encode yes as one and no as zero. If you want to model a span detection, you can categorize the presence of span as one and presence of no span as zero. So how does it work? The model is trained on a label data, as we have said about supervised learning. Historical data with known categories. It learns pattern. It learns pattern. So let's critically look at the step. It learns patterns and relationship between input features and the corresponding class level. We talk about the input features and the targets. So when giving new data, the model predict class to which the data is belong. So after training the model and building it, when a new data comes in, that's why I say in machine learning, you automate your prediction. When a new data comes in, the model should be able to detect, it should be able to predict the class to which it belongs. If it's span, the model should be able to automate whether is span and put it in span in trash, or is not span and it comes to your inbox. So the techniques that is used in classification uh, problems, we have the decision tree. In decision tree, it simply splits data based on feature values to create a tree-like model for classification. We have naive Bayes classifier, uses probability theory to classify data based on Bayes theorem. Support vector machine finds the optimal hyperplane to separate data point into different classes. Neural network, which is extended as deep learning, uses multi-layer of neuron to perform complex classification tasks. Logistic regression, don't mind the regression there. Though it predicts probabilities, it is mainly used for classification problem. So when you see logistic regression, don't think that it can be used for regressional problem. It's still used for classification problem. It is logistic linear regression that is used for regressional problems. So we also have random forest. It's an assembling technique. We are going to look into it when we start building projects or solving problems with it. The random forest can be used for both classification and the relational task. It is an ensemble learning method that operates by constructing multiple decision trees and combining their results to produce a more accurate and stable prediction. So it was introduced by Leo Bremen and De Cotley. So, and it's used for building model because of its high accuracy and robustness. So we are going to apply all these. So these are the steps of uh, how random forest works. But considering the tool we are going to use, we have libraries that we are going to use to work on these things. They have already been automated into a Python library. So we choose to use Python as our tool here. So classification, it continues. This is an example of classification, spam mail detection. Problem, classify each mail as spam or not. Features use email content, sender, subject line, frequency of certain words. The output that is expected is two possible classes. Spam can encode it as one, I've said earlier, or not spam, you can encode it as 0. Flood, fraud detection in banking. We are going to do all these tasks as projects so that I see clearly how you work in real-time scenario. In fraud detection in banking, a problem can be to detect a fraudulent transaction. The features that should be used is transaction amount, location, time, device used. Expected output should be two possible classes. Either you detect that it's fraudulent act or fraudulent transaction, or is a legitimate transaction. It can be also be, you can encode fraudulent as 1 and a legitimate as 0, or the reverse case. More examples: medical diagnosis. The problem to predict whether a patient has diabetes or not on test results. It's also a classification problem. Features that can be used is blood sugar level, age, weight, lifestyle habits. Expected output, two possible classes: diabetic, either the patient is diabetic, which is a yes, or non-diabetic, which is a no. In sentiment analysis, it can also be applied in sentiment analysis. The problem is thus analyze the product reviews to determine if they are positive, neutral, or negative. Features, likely features are words used in the review. Emojis, punctuation, likely output, three possible classes: causative, neutral, or negative. So regressional problem. Regressional problem is used to predict continuous numerical values based on input features. It helps understand relationship between variables and make future prediction. Example is house price. Is a regression is a continuous data, temperature, stock price prediction. Likely techniques, the techniques that can be used for regressional problems are linear regression, multiple linear regression, polynomial regression, rig and lasso regression, and all the regression except logistic regression. So how does it work? The model learns the relationship between independent variable, that is the input features, and a continuous dependent variable, that is a target. It uses historical data to determine a function that best fits the data. When given a new input, the model should be able to predict a numerical value. So relational problem, relational continuous value or numerical value, classification problem is class, either 0 or 1, span or no span, yes or no. Examples of regressional problem, as I've said earlier, house prediction. When you go to my book in Python for data analysis and machine learning, you see a chapter where I did a step-by-step real life scenario of how to train a model. And there, I think this house price prediction is really executed there. I showed how you can train the model and also deploy it in real time using Python and Django. The problem which I have discussed earlier is predict the price of a house based on various factors. And the factors is based on number of bedroom, locations, square footage, nearby amenities. The likely output is a continuous value, possibly example $250,000 as the case as the case may be. Then self forecasting can also forecasting is a regressional problem. Estimate the expected sales for the next quarter. Features use past sales, seasonality, marketing spends, economic trade. So these are the how they automate all those forecasting you do in your forex trade. Output a continuous value. Example, 50,000 units. More example, weather prediction, predict the temperature in a city for the next day. So these are the things that I use to automate all these our weather forecasting prediction for the weather forecasting announcement. Features use humidity, wind speed, or atmospheric pressure output. Continuous value telling you the temperature is 25 degrees centigrade or 30 degrees centigrade or 27.5 degrees centigrade or the like. Stock market prediction. Problem, predict the stock price of a company for the next week. Feature use previous stock prices, market trend, economic indicators, output a continuous value like $150 per share. So when we deploy a model, you see clearly in real time how these things are done. So this is a key difference between classification versus regressional problem. In the feature, we look at the type of output. The type of output in classification problem is discrete. The type of problem in regressional problem is continuous, numerical value in another term. Expected examples of such outputs are span or not span, yes or no. Examples of such a regressional problem, house price, temperature, stock price. The goal of a classification problem is assign a label to input data. While the goal of a regressional problem is to predict a numerical output. The algorithms you can use decision tree, naive Bayes, support vector machine, logical regression, random forest can also be used. In regressional problem, you use all the regressional techniques as many as possible. It's not limited to what we listed here. Use case, fraud detection, medical diagnosis, sentiment analysis. Use case for regressional problems, sales forecasting, stock price prediction, weather prediction. We are going to see it vividly when we start the practical aspect of it. It's very interesting. You see how you can automate model, like building automate your problems to make automatic prediction using machine learning modeling. So prediction, you can hear this word prediction. Prediction is a general term. It's just a general term used to describe the process of estimating an unknown outcome based on input data. So it includes both classification and regression as the subtype. So key points, when you talk about classification, you know what we are talking about. Output is categorical. Regression is a type of prediction where output is continuous. When you hear prediction, it can be applied to other areas. Can be a classification problem or regression problem. It can also be applied to other areas like forecasting future trends, time series analysis, recommendation system. So these are the techniques that they use for other time series analysis. RMA, what you call autoregressive integrated moving average. They use a lot in statistics and mathematics. Long short-term memory deep learning approach. Model data point over time to make prediction. Neural network and deep learning can also use in time series analysis. Random forest and gradient boosting. XBoot, Light, GBM, they all uses decision tree for high accuracy prediction. So real world applications, say forecasting, predictive maintenance, healthcare. These are where you apply it. So these are key differences between the two, which I've explained earlier. And we have said that prediction is generally can be applied in this or that. So let's look at other techniques like clustering, unsupervised learning. Clustering that is a task that groups similar data points together based on their characteristics without predefined label. It is useful for discovering natural pattern and hidden structure in data. The techniques used is k-means clustering, divide data into k groups based on similarity. Hierarchical clustering, build a tree of cluster by either merging bottom up or splitting bottom down. So we have the DB scan, the density-based spatial clustering of application with noise group points that are close to each other with identifying outlier. The good thing about this is that we have different Python libraries to automate all these things. So real world application, you can apply it in customer segmentation. You can also apply it in anomaly detection and general research. Association rule mining is an unsupervised learning. Association rule mining find relationship between variables in live data set. It helps uncover interesting correlation, frequent patterns, and dependencies among different items. So a priori algorithm are the techniques used. FP growth algorithm, frequent pattern growth algorithm is also used here. So these are all data mining techniques. Real world applications. Real world applications, you can apply it in this place, market basket analysis and medical diagnosis. So you see the interesting part of this in our practical class. So these are the review of what we are going to model. We are going to do the practical of these things uh, using Python. So in the next class, we are going to look at the different types of data, structured, unstructured, semi-structured, the different more applications where these things can be applied, and also look at the tools. There are different tools or automated tools that you can use, but I want us to use a programming language that is very, very dynamic and has so many libraries for both data analysis, machine learning, modeling, and also visualization libraries. Python has so many powerful visualization libraries to make visualize your data as you want, and you can write. You have so many dynamic libraries to get your analysis the way you want. So I found it interesting using Python libraries to every other automated tools that might have some limitation. Thanks for listening.